So last time around we have talked about permutation. Now permutation was NPR. So NPR means what? That there are total number of n objects and we are arranging n objects taken r at a time. Taken r at a time. So permutation is similar to that multiplication principle which we have done. So let me just show you an example of the problem. So suppose there are we have to find number of 4 digits, 4-digit number of 4-digit numbers can be formed from 1, 2, 3, 4, 5. Now this question we have already discussed like this in the exercise 7.1. So here we said that there are 5 numbers 1, 2, 3, 4, 5 and we have to find the number of 4-digit numbers we can form by arranging these 5 numbers. So in the previous exercise, how we learned to do this one? We learned to find this by using box method. So in that box we had 4 compartments. 1, 2, 3, 4. And why 4? Because there are 4 digits, so 4 compartments. So the first compartment can be filled in 4 ways. Sorry, it will be filled in 5 ways because there are 5 numbers are there. So the first compartment can be filled in 5 ways. So any of the 5 numbers we can put in the first compartment. Now here another one, here repetition not allowed. Here repetition is not allowed. So the second compartment can be filled in 5 minus 1, that is 4 ways. Why 5 minus 1? Because we have already used one number in the first compartment and the same number we cannot use in the second compartment. So it will be 5 minus 1 or that will be 4. Right? So the third compartment will be 3 ways and so as the last compartment will be 2 ways. So basically by multiplication principle what we could have written that therefore the number of 4-digit numbers can be formed is 5 into 4 into 3 into 2. This was the answer for this question. Now this one we can do with the help of permutation also. So what we are basically doing is that among these 5 numbers there are 5 objects. 1, 2, 3, 4, 5. There are 5 objects. And among these 5 objects, I am taking 4 objects at a time. At one particular time, I am taking 4 objects and then I am arranging the 4 objects and I am getting a 4-digit number. Right? So here the permutation is what? NPR, where N is the total number of objects and R is the number of objects we are taking at a time. So here the number of 4-digit numbers will be 5P4. It will be 5P4. 5 signifies the total number of objects present and 4 signifies we are taking the number of objects at one time. And this, the formula for this one, the derivation of permutation is not there in the syllabus, but the formula for N 5P4, please remember this one, the formula is given by 5 factorial divided by 5 minus 4 factorial. This is the formula. So here NPR will be equal to what? NPR will be equal to n factorial divided by n minus r factorial. So this is how we do permutation. Now with this permutation I will be discussing 2 main things. So the first thing is if all the objects which we are selecting from are different. So let's write in here, my first criteria is if all the objects are not alike. If all objects are not alike. So if all objects are different, it means what? We have 1, 2, 3, 4, 5. Here all objects are different, right? Now if I take 1, 2, 2, 3, 4. So here 2 objects are similar. That is, this 2 are similar. So I am taking the first condition when we have all the objects are not alike, so they are all different, or we can write if all the objects are different. Now in this section there are 2 parts. One part is that repetition not allowed. Repetition not allowed. Now repetition means if I have used that object to fill a compartment, I cannot use that object again. So repetition not allowed. Now we have already done this one. When repetition is not allowed, the first compartment is filled in 5 ways, second compartment is filled in 4 ways, third compartment is filled in 3 ways, and the fourth compartment is filled in 2 ways. So basically when repetition is not allowed, the formula is NPR. NPR. We are having decreasing, it's decreasing. So first one, it will be n into n minus 1 into n minus 2. It will go on like that. First you see it is 5, then 4, then 3, then 2, and then dot dot dot. At the end it will be n minus r plus 1. Like this way it goes, because it is NPR, it's not NP1. If it is what NP1, it would have been up till 1, n minus 1. Now let's do repetition is allowed. Now for repetition is allowed, what we have? If the criteria is repetition is allowed. Now repetition is allowed means that we can use that number again. So it means here, if I look at the figure in here, if I used any number 1, 2, 3, 4, 5 to fill the first compartment, right? So there are 5 ways we fill the first compartment. Now the second compartment we can again have 5 ways to fill it. Why? Because we can use that number again. Suppose I put 4 in here, we can use 4 again to fit in the second compartment, because repetition is allowed. So here if I have 5 ways, then the second compartment can also be filled in 5 ways, the third compartment can also be filled in 5 ways, and the fourth compartment can also be filled in 5 ways. So basically the answer which we will get is the total number of objects, if repetition is allowed, then will be 5 to the power 4, where 5 signifies total number of objects and this 4 signifies objects taken at a time. So basically if I had n objects and we are taking r objects at a time and repetition is allowed, the answer will be n to the power r. Here it was NPR, but here it will be n to the power r. So basically that counts out to be n into n into n, and it will be r times. So these are the two important things when objects are not alike. Now let me just give you one problem in here, an example. So suppose we have a word, let us see in here. We have a word commute. Compute, it is a different thing. Now compute. Now I am asking you, how many 4-letter words can you form with these letters of compute? How many 4-letter words you can form with the letters of compute? How many different 4-letter words we can form? So once you see 4-letter words, so we will be thinking in box method, there will be 4 compartments, and we all have to do what? We have to fill those 4 compartments, right? Okay. And in the same way, we can think of permutations also. So in permutation, how many objects are there? What is the value of n in here? The value of n is 1, 2, 3, 4, 5, 6, 7. So n is 7. And how many objects, how many letter words we are trying to find? We are trying to find 4-letter words. So my r will be 4. So here the compartment was 4, right? Now let's do the multiplication. So how many ways we can fill the first compartment? It will be 7 ways, right? How many ways we can fill the second compartment? It will be 6 ways. Then it will be 5 ways. Then it will be 4 ways, right? So the answer, if the answer which I will get by multiplication principle is 7 into 6 into 5 into 4. But if we do this problem by permutation, what will the answer be? The answer will be NPR, that is 7P4. That's the number of 4-letter words you will get by compute, by the letters of compute. Let me find the answer of this thing. So we will be getting 7p4, right? So that's my answer. So 7p4, now this, it is 7 factorial divided by 7 minus 4 factorial. This is what we have, right? Now 7 minus 4 factorial is obviously there is 3 factorial. So what we get is 7 factorial divided by 3 factorial. Now can I write 7 factorial as 7 into 6 into 5 into 4 into 3 factorial divided by 3 factorial. So like this way, this 3 factorial goes away, and you see the answer which you get is similar to what we have got in multiplication principle. It is the same thing. So permutation is quite similar to multiplication principle. So this is how we do problems when objects are not alike. Now we have a condition when certain objects are alike. So the second most important thing, if certain objects are alike. So what happens for this case? Now for this case, what happens is that I will try to explain this one with an example, that is B. Let us do with an example B. B double E. So how many ways we can arrange this word B, right? And there are 3 letters in here. So I will be arranging only three at a time. So basically N is equal to 3 and R is equal to 3. So I will be taking 3 letters at a time, right? So how many ways we can arrange B? So the first way, you can definitely, what you will do is, let me write this one as B, E, E, and let us write this one as E1, and let us write this one as E2. I'm writing E1 and E2. Now, how many ways we can arrange? Let's see. First way we can arrange is B, E1, E2, then B, E2, E1, B, E2, E1. So B, E2, E1. Then we have E1, B, E2. Then we have E2, B, E1. Then we have E1, E2, B. Then E2, E1, B. Yeah, these are the ways we can arrange, right? So how many we are getting? We are basically getting 1, 2, 3, 4, 5, 6, right? Now here, if you just do the normal permutation, what we are doing? We are taking 3 objects at a time and we are arranging them. So it will be 3p3. There are total 3 words are there. So 3p3, that is equal to what? 3 factorial divided by 3 minus 3 factorial. That is 3 factorial divided by 0 factorial. And we know 0 factorial is 1. So 3 factorial is equal to how much? It is 3 into 2 into 1. And that is 6. And that's what we got, 6. But is that the answer? No, it's not the answer. Why? The reason is that we have written E1 and E2. Now, do English alphabets, do we write like that? Suppose I have a word, what should I say? Room. So in that room, this 2 different words, are they different? Is this one is O1, this one is O2? They are not different. It's the same letter O, right? So here, B, in this letter B, this E1, E2, there is nothing of E1 and E2. So basically what we can say is that this one, what we have is B, E1, E2, then B, E2, E1, they are same. They are to be considered one. They are not different. Then E1, B, E2, then E2, B, E1, they are also same. They also have to be considered one. Then E1, E2, B and E2, E1, B, there also has to be considered as 1. We cannot take them as 2 because they are same thing. There is no such thing as E2 and E1 because both the E are the same letters of the English alphabet. So how many basically ways we are getting? There are only 3 ways we can arrange the letters of B. So the answer will be 3. Now how we got 3? That will be a question. The question is that, look at here, we have found out 3p3. Now here, this is the answer when the 3 letters are different. But here, the letters are similar in here. E1 and E2 are similar. So the problem what we need to do is we have to write here this one will be equal to 3 factorial divided by how many letters are alike? E1 and E2. There are 2 letters are alike. So it will be 3 factorial divided by 2 factorial. That will be the way we should do the problem. Okay. So basically what do we get? It will be NPR. Suppose I am getting NPR divided by the number of it will be 2 factorial because 2 letters are alike, right? So let me just give you the definition of this theorem. So let's write down, if certain objects are alike, what will be the answer of the permutation? Now let me write it down. Okay, so here it will be the number of permutation of n objects where p objects are alike, and rest are different, is given by n factorial divided by p factorial. So here total number of objects was 3. So it was 3 factorial divided by, and how many objects there were equal? Same, that is 2. So it will be 3 factorial by 2 factorial. That was my answer. So if you do 3 factorial is 6 and 2 factorial is 2. So we'll get the answer as 3. So number of permutation of n objects where p objects are alike and rest are different is given by n factorial divided by p factorial. So this is the way to do it. Now let me just go through one of the problems. Suppose we have the word digit. Let's do one example. Suppose we have the word digit, and how many ways we can arrange this word digit? Okay, that's my question. How many ways we can arrange this word digit? So what we will do? So the number of ways, the permutation is what is the value of n? N means what? The total number of digits are there. 1, 2, 3, 4, 5. There are 5 letters are there. So it will be 5 factorial divided by how many same elements are there? 1 and 2. There are 2 equal elements are there. So it will be 5 factorial by 2 factorial. That will be my answer for the number of ways we can arrange the words of digit. Okay. Now there is one last portion of permutation, and it falls under this criteria that objects are alike. So let me just go to that one, the last portion. Let's write down. So the last portion says that the number of permutation of objects of n objects where p1 objects are of one kind, then p2 objects are of another kind, p2 objects are of another kind, and pk are of kth kind. So here we are doing permutation of n objects where p1 objects are of one kind, p2 objects are of the second kind, and pk objects are of the kth kind. Okay, so how to do the permutation of this one? For this one, it is given by n factorial divided by p1 factorial, p2 factorial, p3 factorial, dot dot dot, pk factorial. That will be the permutation of n objects when certain objects are of same kind. So let's do a problem related to this concept. So we have one example, and let's write, let's select a word. Suppose we have in here, wait a second, let me find a word. Independence. Independence. So this word, we have to find a ways, the number of ways we can arrange this word. So first thing, what you see is, how many letter word is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my n is equal to 12. It is a 12 letter word, right? Now after noting it is a 12 letter word, now we'll find how many elements, how many letters are similar in there. So here, if I look at I there is only one. Now if I look at n, how many times n is there? n1, n2, n3. So n is 3 times present, right? Now let's check D. How many times D is there? D is only once, so I don't have to consider on D. Now look at E. E is once, twice, thrice, fourth time. So E is used 4 times in here. Now P, now again if you look at P, now if I look at P, P is used twice. So 1, 2. So I will write here P2. Right? So these are the letters which are repeated and the rest are used once. Clear? So now we have to find what the permutation of the letters of the word independence, and what will be the answer. The answer will be given by n factorial. Now n factorial is what? 12. So it will be, I will just write 12 factorial divided by n, the letter n is repeated thrice, so it will be 3 factorial. The letter E is repeated 4 times, so it will be 4 factorial. And the letter P has been repeated twice, so it will be 2 factorial. So if let's cut this one and then let's get the answer. So this one will give us the answer for the number of arrangements, the permutation of the letters of the word independence. So the answer will come out to be, so let's see, the denominator is 3 into 2. This one is 4 into 3 into 2 into 2, and how much we are getting? So 12 into 11 into 10 into 9 into 8. I think it will be done up till here. So what we get is, so this one is 6, that's 2, so 2 gets cut, 3 here is 3 gets cut, so 2 4, that's 8, this 8 gets cut. So what we have, this one is coming out to be 330 into 7 factorial. So basically you have to find the value of 7 factorial and then multiply with it 330, and you will get the exact answer of this problem. Okay.